to ask questions on these, because remember, we talked about how really important factoring is and being able to break these things up into pieces. So any questions on these first few? Now, you don't have to have it pulled up or anything, but if anything stood out to you, if you especially had trouble with one of these, I'm guessing maybe 5 and 6. Maybe, maybe not. Those were not quite as bad because you've got the multiple choice answers there to help you out. This is something that we've talked about a little bit, and we'll be talking about more, how to simplify rational expressions. So remember, you always want to factor and then cancel it out and then write it out more neatly. So when we multiply straight across. Now, lots of people want to go ahead and multiply this out. That actually makes it harder than it has to be. So looking at this one, we've got w squared plus 2w minus 8. I factored that second piece out, so I left the w squared there, and then factored this piece into w plus 4 and w minus 2. Okay, and then across the bottom, w minus 2 can't be simplified. It can't be factored out or rewritten in any way. But w squared minus 1w, they both have a w in common. So we can factor out that greatest common factor and get w times w minus 1. So that's when I want to simplify that a little more and factor out or cancel out what I can. So w minus 2 and w minus 2, those match up, and since everything's being multiplied across here, I can cancel those. And then w squared over w, I kind of wrote it funny, but we know that 2 minus 1, if we're going to simplify that, just leaves us with a w left over, so it kind of gets rid of that squared. Okay, yeah, I'll go back and do number 5. So when we cancel out that w minus 2 and that w squared over w simplifies to just w itself, this is what we end up with. W times w plus 4 on top over w minus 1. I've said w so many times it's starting to sound funny. Okay, so that's a great answer. If you decided you wanted to distribute that out on top, that's fine, but you don't have to. Don't do more work than you have to do. Okay, so whenever we get to stuff like this, and you guys are to the point now, you're going to be moving on to trig and pre-calculus and all that good stuff. So this is really how we want to leave it, because we might want to do something else with this where we would have to factor it out, and that just saves us a step. Okay, let's slide back up to number 5. So it's been a while since we did anything that looks like this. I'm going to slide over so I can write. Ooh. So on number 5, we're supposed to divide this whole thing by x plus 3. So remember, we have 2 choices on that. We can do long division, which we decided was really nasty and we didn't really love a whole lot, or we can do synthetic division. So remember, synthetic division, when we're dividing by a binomial like this, the opposite of this number is what goes in the box. Let me write this in a marker so we can see a little better. So the opposite of this number is what goes in the box. So we're going to put -3 in here. Now, beside the box, we put all of the coefficients that are over here, and we have to make sure it's in descending order and we don't miss any exponents. So this is 3x cubed, so that's to the 3, minus 3x to the 2, minus 3x minus 4. So 3, 2, 1, and then no x's here. So we're just going to put all of those coefficients beside it. We've got 3, -3, -3, and -4. So just these numbers out front in order as we see them. okay? Now then, this is always the same. The process that we go through is always the same no matter what numbers it is that we're dealing with. So we're going to bring this 3 straight down. It doesn't matter what the number is. It could be 1 or -2 or whatever. But we're going to bring that number straight down. Now we start this process. We take whatever's in the box and we multiply it by whatever we have on the bottom, and then we put it in this spot, and then we add those together vertically. So it's like we keep making new addition problems as we go. So I'm going to grab a calculator just so I don't make any careless mistakes on these. Make sure I get the right answer, right? Okay, so -3 times 3 is -9. And then we just combine these. -3 minus 9 is -12. Now we keep going. -3 times -12 gives me a +36. So it goes in this next spot, +36. -3 plus 36 gives me 33. We're going to do the same process again. So -3 times whatever we have on the bottom goes right there. So -3 times 33 is -99. And then -4 minus 99 is -103. So when we write the answer, we always start with an exponent that's 1 less than the one that we started with. So we started with a 3 right here. Can't tell you guys how excited I am to have my document camera back. So we started with a 3 right here. So we're going to drop down to a 2 when we write it in my answer. So this is going to be 3x to the 2, and then we're just going to follow along. Minus 12x to the 1 plus 33. So we've got 2, 1, no x's. And then the remainder, that's always this last piece is the remainder. The remainder is -103. So that's why it's that D answer. See how that matches up? 3x squared minus 12x plus 33 with a remainder of 103. So any of those where it asks you to divide, or if it tells you like on number 6 that this is a factor of this whole thing, we want to break it down into 2 pieces. So if you were to divide this by x plus 1, you would end up with something that looked like A. So you would have that x plus 1, and this would be the answer that you got. So it goes back to that synthetic division that we talked about a long time ago. We might add a review in on that just to make sure. So guys, just remember, I'm going to make a note so I don't forget. Just remember that all of this work that we're doing, I'm picking out the most important stuff. So regardless of what math class you're going into next, I want to make sure you're prepared. So I don't want you to get to a pre-calculus class with me or a trigonometry class with Mr. Powers, or maybe you're getting close to college and you're going to be doing some college algebra or something like that. I want to make sure that you know what you need when you get to those classes. So I'm picking out the most important stuff so that when you get there, you're not behind. I don't want you to get into a new class and go, oh no, I've never learned this. That darn coronavirus, right? So we're going to make sure that you're prepared. So not just we're improving your grade, and we're preparing you for your next courses. Okay, what else do we need on that first page? Was that helpful? Hopefully a good refresher on synthetic division. I'll leave that there just a second and then we'll turn the page. Good deal. All right, I'm going to turn the page over. There's a couple more of these on the back. We might have to do another one. Okay, so again, I will be checking these and giving you feedback on your work. But this is just so that you can see it and we can talk through it if we need to. Because when I write on your work or whenever I give you that feedback, sometimes it's hard to communicate these are the steps and this is how you do it. So that's why we're doing this right now. So I have a feeling, based on comments that I got on the assignment, we might need to look at 11 and 13. Are there any other ones through there, any of those factoring ones that were just a little bit difficult we need to look at? Hopefully on number 9, we remembered this keep, change, flip process. So when you simplify two fractions that are being divided, that's a division sign. It kind of looks like a plus, but it is division. So when we're looking at something that's being divided like that, we keep the first fraction, change this to a multiplication, and flip this fraction over. So what we're really dealing with on number 9, we're going to keep the first fraction. So keep this exactly the way it looks. Change this into multiplication. And then flip this one upside down. So the bottom goes to the top. And the top goes to the bottom. Just like that. Then we can factor and cancel, and then we get this. So I think the trickiest part on that one was remembering that keep, change, flip step. And remember, that's true no matter how nice or ugly your fraction looks. Number 10, we just needed to factor and cancel and rewrite that all nice and neat. I'm going to skip 11 and 13 for the moment. 12, factoring. This is a difference of perfect squares. So remember, x times x is x squared. 3 times 3 is 9. So we put an x and a 3 in each of our binomials, and one's a plus and one's a minus. Okay. 14 and 15, these would have been the slide and divide problems. So they were some of the harder ones that we dealt with. So slide and divide. On number 14, you would have gotten 4x minus 3 times 4x minus 3, but I was just trying to save some room by writing 4x minus 3 squared. 16 has a greatest common factor of 2 that we could have taken out first, so we didn't have to slide and divide. And then number 17 was just a regular old factoring problem. Anybody need to see 15 or 16? If so, if you can just tell me what number. You can type it in or unmute. There's not that many of us here. I don't think we'll talk over each other. Okay, I don't see any requests. Let's try looking at 11 and 13. Do we need to do both of those? Maybe 11 and 13. I'm going to write them on a separate sheet of paper so I can show it. Thank you guys for typing stuff in the chat box. It really helps since I can't see your faces. Anything in the chat box is helpful. This is all whatever you need. That's what I'm here for. Okay. All right. So 11 and 13. We will do them both. No big deal. I'm going to write them over here. So we're going to divide. Make sure I write it down correctly. That'd be awful if we were doing the wrong problem, huh? Okay, so it's really important that we have our terms in descending order. So that just means the biggest exponent down to the smallest exponent, and that we don't have any gaps. So if we look at the exponents on these x's, we've got 3, 2, 1, no x. So that's great. That's exactly the order I want it to be in. Remember, we're going to put the opposite of this number in the box. So this is just like the synthetic division on the front. But apparently these were a little bit ugly. So let's make sure we can get the right answer from this. Okay, so all I did was take the coefficients from all of these, -5, 16, -23, and 22, and write them next to that +2 in the box. Now we're going to go through the same process. Okay, we're going to bring down the -5. And then we're going to start multiplying. So we multiply by whatever we have down here. So 2 times -5 is -10. And then we combine these. So it's just like if we got rid of everything else here, and that was just an addition or subtraction problem. So 16 minus 10 gives us 6. So that's how that works. So if we can make it a simplified problem, that's definitely what we want to do. So from here, we're going to multiply 2 times 6 gives us 12. And if it helps, if it's a positive, go ahead and write a plus so you remember to add. So I've got -23 plus 12 is -11. And then 2 times -11 is -22. So look what happens here. 22 minus 22 is 0. So that means we have a remainder of 0. That means that this is a factor. It divides evenly. So like we say that 2 is a factor of 8 because 2 goes into 8 4 times. We don't have a decimal or anything left over. So that's what we're looking at when we have a remainder of 0. Just like the last one, we're going to go one less than whatever the biggest exponent was. So this is going to be -5x to the 2 plus 6x to the 1. You don't have to write it, or you can, minus 11 no x's. So on number 11, this is the answer you were going for. Okay. So there's one of them. Let's try 13 too. Now, if you haven't turned this assignment in yet, I know not everybody has, then that's what I'm here for. I'm helping you work through these. So now you have them done. As long as you've gotten through them, that's great. That's the whole point, is for you to know the process and be able to do that later on. So if you haven't turned it in, remember you've got these that you can fall back on. And if you have already turned it in, I'll give you that feedback. But if you've been here and worked through them with us, then you'll already know what those answers are, and you'll know what my feedback says before I even send it. Okay, so number 13, we're going to divide -x to the 3rd. Now remember, if there's no number there, we just fill in a 1, right? So this is x to the 3, 2, 1, no x's. So there's no gaps. It's not like I skipped any numbers. And we're supposed to divide by x minus 3. So we're going to put the opposite of that in the box. And then put all of these coefficients beside it. So -1, 2, -2, 2 again. Okay, same process. We're going to move that -1 down. And then whatever's in the box, this time it's a 3, we're going to multiply by what's on the bottom and put it in that next blank spot. So it really helps if you keep this nice and neat. If you can keep it lined up pretty well. 3 times negative 1 is negative 3. So 2 minus 3 is negative 1. 3 times negative 1, negative 3. Negative 2 minus 3 is negative 5. 3 times negative 5 is negative 15. And 2 minus 15 is negative 13. So remember this last spot, sometimes we draw a little divider right there so we remember that this is always the remainder. So this one's going to have a remainder. That means x minus 3 was not a factor. It would be like trying to divide 8 by 3. 8 divided by 2 is 4. 2 and 4 are factors, but 8 divided by 3 gives me a decimal, so 3 is not a factor of 8. So it's the same thing, it's just on a different scale. So when I write this answer down, remember we're going to go 1 less than what we started with. So we had an x cubed in our problem as the biggest exponent. This is going to be negative 1 x squared minus 1 x minus 5 with a remainder of negative 13. Now you can put those ones in. I definitely would not count off for that. That means the same thing. Just know if you were going to match it up with a multiple choice answer, that it would probably be written this way. So with or without the ones is fine. Okay. So I hope that helped on those. And then the last 3 on the bottom of that page, 18, 19, and 20, were just some practice on exponent rules. So if you turned those in, I'll check them. Do we need to talk about any exponent rule problems? You can ignore that bit on the bottom, but just 18, 19, and 20. Yeah, I can do 19. 19 definitely is the trickiest one. Anybody need 18 or 20? Well, hopefully not 18, right? Because everything is being raised to the 0, and anything to the 0 power is 1. Anybody need 20? If you decide you do, type it in the box. I'm going to work through 19. So on 19, that negative 3 on the outside kind of throws us off a little bit. Okay, so there are 2 different choices that we have on this one. We can move everything to the bottom of the fraction so that we can make that negative 3 a positive 3 and we can deal with it from there, or we can go ahead and raise everything inside here to the negative 3. I kind of like moving it to the bottom first, just so I don't have to deal with that negative and possibly some extra fractions. So I'm going to do it that way, but if you don't like it, you let me know. So this is what I'm going to do. I'm going to take this whole thing and I'm going to move it to the bottom. Now, it's going to change this into a plus 3. If I'm changing an exponent on the outside, I don't have to change everything inside. I can't change that yet. I just have to do one layer at a time. So this is going to end up being 1 over 2x to the 5th, y to the negative 2 to the positive 3. So it changed the sign on that last piece. Now I can raise everything inside that parenthesis to the 3rd power. So 2 cubed, I'm going to leave that 1 on top. We'll address that if we need to. 2 cubed is 8. And remember, when we raise a power up to another little power, we multiply. So 5 times 3 is x to the 15th. And y to the negative 2, we've got negative 2 times 3 is y to the negative 6. So remember, we don't want any negative exponents in our final answer. So the only thing we need to do to fix this is move whatever piece of it is negative across the fraction bar. So I'm going to move that y minus 6 up to the top. So I'm going to write my answer down here actually so we can see it. Y to the positive 6, once it moves across, it changes signs, over 8x to the positive 15. So this will be in the next packet or in the next Google Classroom assignment. However, you're looking at your work. This is what we're going to be doing next. And this is super important. It's something that you see in lots of other classes. So we talk about it a lot in pre-calculus. It's a whole section. So if you know kind of the background of it, when you get to pre-calculus or trig or whatever, you'll definitely be prepared and be able to move on without being lost. We don't want that. Okay, so rational functions and their graphs. And you can follow along. You can follow along. I will post these in Google Classroom, so you'll have it to look at. It'll probably be a nicer copy than the one I'm writing now. But we talked a little bit at the end last time about what happens when you divide by 0. So if you were here last Monday, we talked a little bit about things that look like this. So what happens if you have x squared over x squared plus 1, and we had that funny looking graph with the dip in it. Then we did one like this where the x plus 2 canceled out, and we ended up with that hole where the denominator was equal to 0. So at x equals -2, there was a hole in the graph. And I showed you how your calculator or Desmos doesn't show you where that hole is. So it just looks like a regular old graph, but we have to know what it looks like. The other thing we need to look at is what an asymptote is. So we talked about it a little bit. Again, it's one of those lines that the graph doesn't touch or cross. So in this graph, I have a vertical asymptote that goes up and down, vertical. And then I have a horizontal asymptote that goes side to side, across horizontally. And that just kind of breaks my graph up into pieces, and I can look at each piece and I know where the values are. It helps me when I'm looking at the domain and range for that graph. So a couple of important things. The difference in a continuous graph and a discontinuous graph. Now, the only thing this means is a continuous graph, I can trace it across my paper without having to pick up my pencil. So for this one right here, this is a continuous graph. I almost said giraffe. This is a continuous graph because I can trace it across my page and I don't ever have to pick up my pencil. It doesn't jump from one place to another. It doesn't have a hole in it. It just goes on forever. It's continuous. There's no gaps or jumps. This graph is discontinuous because it has a hole in it. So if I trace this graph, I trace it to here, and then, there's a hole. I have to jump over it. So I had to pick my pencil up because I couldn't trace that part. And then I go on up. So discontinuous. This one's discontinuous too for a whole other reason. If I trace this graph, I'm going down forever. And then to get to the other part of the graph, I have to pick my pencil up, move up to the top, and then I can trace the rest of it. So these two are discontinuous. This one is continuous. Okay. So continuous doesn't have any holes, it doesn't have any jumps, no breaks. I can trace it with my pencil without picking up my pencil at all. Discontinuous means that we're going to have holes or jumps or breaks. We're going to have to pick up our pencil to graph the whole thing. Okay, so I'm going to talk through this. I've got about 3 minutes until my time is up. So I'm going to show you this so that whenever you do your work, you can see and understand what this means. And now that I have my document camera, your notes should be a little more easy to follow. Okay. So when we talk about horizontal asymptotes, we've got 3 different cases. Okay. So if we were to graph x squared plus 2x over 2x minus 5, remember the degree is the biggest exponent on that side. So the degree on top is 2. The degree on the bottom is 1. And if you guys will be patient just a second, I'll type this in so you can see what it looks like. So I've got x squared plus 2x on the bottom, or on the top, sorry, and 2x minus 5 on the top. Oh, it looks like I've got another. There we go. Ooh. The puppy just moved. Okay, so this is what that graph looks like. Notice that these 2 pieces, even if I go on over, an asymptote is something that it gets really close to. So if I draw a line, and don't worry, I can erase it. But if I draw a line through here, notice that the top part of the graph is getting closer and closer to that line but never touches or crosses, and the bottom part of that graph is getting closer and closer to that line but never touches or crosses. I know I have 2 different pieces here, but there is no line, even if I draw it here in between, they're not getting close to that line. That's the definition of what an asymptote is. It's getting closer and closer to it. These are going further and further away. So this graph does not have a horizontal asymptote. Ta-da, no horizontal asymptote. Okay. So we have 3 different cases. If the top degree, let's look at case number 2. If the top degree is bigger than the bottom, so just like this, the top degree was bigger than the bottom, then we have no horizontal asymptote. Okay. If the top degree is smaller than the bottom, so if I flip-flop that around, then the horizontal asymptote is always going to be equal to 0, y equals 0. It's always going to be the x-axis. So something that looks like this. And I lost my other color pens. The x-axis would be that horizontal asymptote. So it's getting closer and closer. Anytime the top is less than the bottom degree, we're going to have that one. The trickiest one is case number 3. If the top degree and the bottom degree are equal to each other, so like this example here, I've got 3x squared and 2x squared. The biggest exponents are the same. Then it's going to be y is equal to the ratio of the coefficients. So see how the coefficient here is 3 and the coefficient here is 2? The horizontal asymptote is going to be y equals 3 over 2 or 1.5. So this horizontal asymptote would be right along there. And it just shows me where it breaks up. So those are the 3 cases. I think this is the hardest part about graphing rational functions. You can look at the calculator and kind of tell or get a good estimate, but sometimes you really have to have an exact value. So when it comes to horizontal asymptotes, the best way to figure out what they are is to memorize your 3 cases or your 3 rules. Now, again, you don't have to worry about copying it down right now. I will post it on Google Classroom, and that way you'll have that access to.